Hey mathematicians, all right, in this lesson we will be efficiently dividing fractions and we're going to be using the algorithm. So we've already learned how to divide fractions using a model. So now we're going to use the algorithm, which is that step-by-step, here's how you solve it. So let's see, I've got 2 divided by 1/2, or how many groups of 1/2 can I get out of 2? The algorithm for this is actually this idea of inverting the second fraction, so using its reciprocal and then multiplying across. And so the way that the algorithm looks is like this. I'm going to change 2 into a fraction, and the way that I do that is I just divide it by 1. Any whole number divided by 1, or in fact any number divided by 1, is still the same number. And instead, so I'm going to keep, I'm going to show you this idea. I'll probably keep using this language of keep the first fraction, invert the second fraction, and then multiply. And I have a good friend named Kim, and so it helps remind me of Kim. Keep, invert, multiply. And so what I'm going to do is I'm going to keep the first fraction. That's always the case. And then I'm going to invert this second fraction so that 1/2 actually becomes 2 over 1. And then I'm going to multiply. Now, because it's a multiplication, we've learned that the algorithm is just multiply across. So 2 times 2 is 4. 1 times 1 is 1, and 4 divided by 1 is 4. The algorithm keep, invert, multiply works here, and we find that 2 divided by 1/2 is 4. All right, let's go ahead and try another one. This is the same type of problem. It's just with a fraction and a fraction. So 3/4 divided by 1/2. How many groups of 1/2 can I get out of 3/4? I'm going to use this same idea of Kim. Keep, invert, and multiply. Let's see. I'm going to keep the 3/4. That's the one I'm going to keep. You can see it stays exactly the same. I'm going to invert the second fraction. So I'm going to make it its reciprocal of 2 over 1 instead of 1 over 2. And then instead of dividing, I'm going to multiply. And because, again, it's multiplication, let's just multiply numerator by numerator. 3 times 2 is 6. And 4 times 1, the denominator by denominator, is 4. This equals 1 and 2/4, which equals 1 and 1/2. So I can see that 3/4 divided by 1/2 is 1 and 1/2. All right, let's try an algorithm-based problem with a mixed number. I will tell you that the same idea, this Kim idea, this keep, invert, and multiply works. What we need to do though is change that mixed number into an improper fraction. So I'm going to make 2 and 1/2 the improper fraction of 5/2. And I'm going to keep that just like it is, 5/2. And I'm going to, I'm sorry, excuse me, I was going to divide, but I'm not. I'm going to invert. So I kept, so keep the first fraction, invert the second fraction. 1/2 becomes 2 over 1. And then I'm going to multiply instead of divide. 5 times 2 is 10. 2 times 1 is 2, and 10 divided by 2, or 10/2, is 5. So 2.5 divided by 1/2 is 5. You can make 5 groups of 1/2. All right, we're going to do one more here, and this time I'm dividing a fraction by a mixed number. So again, remember this idea of Kim, my good friend Kim. I'm going to keep the first fraction, 2/3. I'm going to invert the second fraction, but you can see that it's a mixed number, so I'm going to turn that into, so I'm going to make 2 and 1/6 an improper fraction. So it would be the same thing as saying 13/6. So I've converted that mixed number into an improper fraction, and now what I need to do is I need to invert it, so that really what I'll have is 6 over 13. You can see that I've just inverted that fraction. And then the last step in the algorithm is to multiply. So 2 times 6 is 12. 3 times 13 is 39. And all right, and 1239. So let's see, is there a common denominator? There is. 3 fits into both. 12 divided by 3 is 4. 39 divided by 3 is 13. So we can see that 2/3 divided by 2 and 1/6 is 4/13. So in this lesson, we learned to efficiently divide fractions by using an algorithm.